Hello, welcome back. And in the last episode, we fixed the major physics bug, but the Tetris blocks aren't behaving a whole lot like Tetris blocks, and the reason for that is because when they collide, they don't continue to slide to the ground. They stop the instant they collide, which means they don't really behave very much like Tetris at all, now do they? So we're going to go ahead and fix that today by making it so that they fall to the ground and they only stop when they hit something that pushes up against them. I've started up MonoDevelop ahead of time because it tends towards errors, and here is the on-collision enter that we normally work with. What we are going to do is, first things first, we're going to put this up at the top, and then we're going to add in an if statement. If collision dot context 0 dot normal dot y is less than 0.5f return. We're also going to go ahead and print that out. So basically, we're saying that if the normal doesn't point upwards, then we don't care. And that should mean that we end up with this should stop immediately. Bam. Yep, and you can see that it worked fine. But now if we were to slide along the side here, see, so if I pause this and go over what just happened, what we have here is we collided with the Tetris chunk, and the normal was -1, that means x, and that was when we collided with this brick here. So we collided with this brick here, and then we continued to slide down, and then we hit this brick here, and that's the second one here, collided with Tetris chunk at normal. And that's what we would like, except for the small fact that we collided with this brick due to physically pushing this brick out of the way, which means that, that's something that we shouldn't have been able to do, because that means that you can shove into these bricks. And we're going to go ahead and resolve that by actually forcing these objects to adhere to a grid. So when I do this, I'm going to make it's not this brick's fault for getting shoved out of the way. It's this brick's fault for shoving through the brick. So what we're actually going to do is we're going to limit this whole chain of bricks when it's still a whole chunk, when it's still a tetramino. We're going to tell that brick that it can't move into another brick. It can't move right if there's another brick. And this is actually going to form the foundation for our score checking, our line fulfillment checking as well. So the way we're going to do that is we're going to perform raycasts from these bricks here, from each of these chunks. We're going to perform a raycast in the direction we're trying to go, and we're only going to go in that direction if it's empty. So we go over here into chunk element, and we can do that. What we would like to do is we would like to have a new function that allows the block controller to query all of its chunk elements and ask it whether or not that it's free to move in a certain way. So public bool can slide in direction vector3 direction. And we'll just do a quick little raycast. So ray equals new ray, and the ray is a very useful tool to build when you're working with physics. A lot of stuff is raycasting. If you're not using raycasting in your physics, I'd be surprised. So it's good to understand how rays work. They're just two vector threes, an origin and a direction. So the direction is obviously direction, but the origin has to be our current position. So there we go. There is the ray. Except, is that actually what we want to do? Because our current position won't be at an integer value. So our current position may actually be offset, and we may be like about to clip a brick or something like that, and it wouldn't work out. Since we're guaranteed to be moving downward, what we really should do is we should create an ideal position. and then the ideal position dot y equals mathf.min ideal, sorry, not mathf.min, mathf.floor ideal position dot y. And that way we won't have to worry about being just above where we're trying to go. We'll always be at the right position. So ideal position. So now we just do a quick little raycast, which we do by creating a raycast hit. You don't always need a hit, but most of the time you will. And the reason we have to define it like this is because of the way that the physics raycasting works. So I just need to make sure that we have... This is brilliant interface. It's totally worthless. I can't tell... Alright, so do you have a... Why can't I... Oh, I guess I have to press down on the keyboard. Alright, so here we go. Looking for the one I want, which is... I have them backwards. So it's ray out hit and then float distance. So that's what we would like to see. So physics.raycast just returns a Boolean. If it hits something, it returns true. If it doesn't hit something, it returns false. So what we do is we load all of the actual information about the hit into the hit variable. So this comes out configured with all of the information that we need. But we don't actually really care about that, so return false, return true. Because if it raycast hits something, then it's always going to be illegal. But not entirely true. If hit.transform.parent equals transform.parent, return true. So if it's part of the same brick, then obviously it can move in that direction if the other brick can. So that's okay. However, if it runs into something that's not part of the same brick, then it's no good. Alright, so can slide in direction is our new tool here. And over here in block controller, we're going to do the exact same thing. Can slide in direction, vector3 direction. And we just work through all of the tetramino elements, all of the bricks, and ask them the same question. So we can either do that using this game object.getComponents in children, or we can just go through each of our children. I don't think we're going to see very much slowdown. We can optimize this out if we do end up with some slowdown by simply scanning once when we first spawn in and storing it. But I think that would be premature optimization. I don't think we have to worry about that at the moment. If not, kids a dot can slide in direction return false. So if any of our kids can't slide, we can't slide. It's easy enough, right? So what do we do up here? This is in our update when we do our velocity x blah 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 blah. We actually want to check here whether or not we are currently able to move in the direction we want to move. So we say if can slide in direction new vector3 hors 0 0. If not can slide in direction, then hors equals 0. So we're saying if you can't go in that direction, don't even try, and we'll also go ahead and put in a console. That way we'll be able to tell why we're not sliding. Alright, so let's go ahead and hit play and see whether that works. So it should work fine, but it doesn't. It actually has an error here where it's impacting with itself. So let's go ahead and add in some stuff here. Debug.log element at transform.position plus collided with element at plus hit.transform.position. Alright, so what does that have to say? So it's definitely colliding with itself. So this brick and this brick are colliding. Yep, that's what's happening. But they should have the same parent, so I'm not entirely sure why they're colliding. Um, hit.transform.parent equals transform.parent. You know what? I bet that it counts as its own parent. I bet that rather than this raycast counting as hitting an individual brick, it's counting as hitting the parent that contains those bricks. We can do that by simply printing out the name. Yep. So it is actually counting as colliding with the parent. The reason for that is because these individual bricks have box colliders, but this is what has the rigid body. So you'll never actually collide with another brick, you'll only collide with the rigid body parent. And that means that what we actually need is if hit.transform equals parent. So if it is our parent, then it doesn't count as colliding, because we can't collide with ourselves. And that fixes it up just fine. Bonk. So let's go ahead and see whether or not we can have that error we had before. Nope. Cool. Works great. Now we have lost something, and that something is the beauty of bouncing physics bricks. So that's what we're going to re-add in the next episode. Also, it looks like there's a couple of bugs in how we treat it, so we're going to have to figure that out as well. It looks like it works going right but not left. How interesting. Huh. Why would it work going... Why would it fail? Why would it... Going left is okay, going right is not. Let me look into that real quick. Well, I added some debugs, and it may just be that I'm not feeling very well, but I think that the problem might just simply be that we're not normalizing the direction that we're trying to slide. So, first off, if we're not trying to move, we don't need to do this. I just realized that I was doing a whole bunch of ray castings in no directions, which is pretty worthless. So here, we're going to go ahead and say that this needs to be a normalized value. There we go. And that should slide in that should check for sliding in increments now. So as we come down, hit right, hit left, and that is the correct amount. So the question is, when I come down like this, and then, so that actually worked. I think that that was the problem. I think that I was scanning less than I should have, and it wasn't actually colliding with the neighboring brick because it was stopping before it got that far. Because moving left and right, when I was only tapping, it wouldn't get all the way to 1. It would be at like 0.3, 0.4, 0.5. Anyhow, that's it.